Welcome to yet another session on data engineering. In this session, we are going to see how we can create a data lake in Azure. Microsoft Azure is one of the leading platform as a service in the cloud. The other two leading platform as a service provider are AWS or Amazon Web Services and Google Cloud. You can get an account in Microsoft Azure with $100 free credit in case if you have a Microsoft account in with an academic institution. So usually Microsoft acknowledges some of the domain names as academic domain names. Like in India, we have .ac.in or .edu.in. So these are considered to be academic domains. And if you have a Microsoft ID in this academic domain, then you can avail of $100 credit without providing any credit card. You just have to search for Azure for Students and you can click on this link for Azure for Students free account credit. It will ask you some information like your your institute or university name, your email ID, which should be again an academic institution's email ID, like as I said, .ac.in or .edu.in, and few other information. It will ask you to validate your academic ID by logging into your email ID with the academic ID, and then it will give you $100 credit and you will be directed to this particular screen, which is basically the Microsoft Azure screen where you can build various types of platforms. In case you don't have an academic ID, you can still go for pay per use, but in that case, you will need a credit card to create an account. So while the fundamentals of platform as a service remain same across most of the leading platforms, the various components are different from AWS to Azure to Google Cloud Platform. In this particular course, we are only covering Azure. Primarily, we might see a little bit of AWS towards the later part of these sessions, but primarily we're covering Azure. One of the reasons for covering Azure is this is the only platform where students can create an account without having to give credit card, provided they have an academic ID. Now, this is the home page that you see over here. And what we are trying to create here is a data lake. As we mentioned in our previous session, a data lake is like a dumping ground for all types of data. And in today's organization, because data is of various types, we need such a dumping ground. So we'll create that data lake and we will see some of the basic configurations that are needed while we are creating the data lake. So all the services are available here. You can go through all the services. Alternatively, you can just search for data lake. Now here, when you search for data lake, you will see there are two options. One is data lake storage Gen 1. The other is a storage account with the keyword data lake Gen 2. Now, more and more platform service providers are opting for this word storage account, which essentially means that any type of data can be stored over here, and these are persistent storage account. And that's why you see this coming under storage account. But you know that this is a data lake because here the keyword is data lake Gen 2. Data Lake Gen 1 was the previous version. This still is present here because some of the clients of Azure may be still using Data Lake Gen 1, but obviously the new clients will always move to Data Lake Gen 2. We will be working on Data Lake Gen 2. Let's go there. Now, this is the place where we're going to create the data lake Gen 2. It is called a storage account, but essentially this is one of the important uh, ways to create data lake. There are other types of data lake as well. Okay. For example, in searching, we saw some HD clusters. So that also can be considered as a data lake. So there are different types of data lake, but this is one of the most popular ones. So first thing you see, there is a subscription. So moment you sign in with your student ID, you get this subscription of Azure for students where there's $100 credit. Now there's something called a resource group. A resource group is essentially a folder or an umbrella under which all the resources that are required to perform a particular job can be saved. So when we are going to build an entire pipeline, uh, we will require multiple services. Right now, for example, we will be requiring only one service because we are just building a data lake. But if you have to build an end-to-end service, we'll require multiple services. And if all of these services can be grouped together under one group, under one resource group, it is easier to manage. In an organization, there can be many such resource groups having different types of services. It's like a folder, the way you arrange folders in your local directory in your computer. In the same way, you can manage your resources under a resource group. So we'll create a new resource group. You need to ensure that the name of the resource group is unique in the sense that there is no other resource group in the same with the same name in the particular zone where this data lake is being created. So one way of ensuring that is that you can use your own name and then use the suffix based on the type of service you're going for. For example, if you're going for resource group, you can give a suffix of RG, and usually that way you find a unique name. Of course, if somebody has created the same name, then probably you have to use some other suffix like a year or some date or something like that. That way you can make it unique, or you can use any other naming convention. This is totally up to you, the name that you want to put. As long as the name is unique, Azure is going to accept it. This is where we'll put the storage account name. So again, we'll follow the same condition, name, and then because we are making a data lake Gen 2, we'll call it DL2. Now there's something called a region. Now what is a region? We all know that these cloud service providers have huge servers in something called server farms. And these server farms are located in various parts of the world. It's a good idea to uh, build your services or build your resources in a server farm which is located nearest to your users, because that will ensure that the latency is low. Okay. Users don't have to wait for the data to be retrieved. Okay. So in my case, Central India happens to be the nearest location. So I've selected Central India, but as you can see, various options are there. According to your place, you can select some other locations. We will not get into primary service as of now. So I'm deliberately skipping some of the more advanced configuration here because our objective is to just to get an idea about how all of these platforms work and how data engineering overall works. But of course, in order to work as a professional data engineer, you typically would need to do a certification course on any of these platforms like Azure or AWS, which obviously is much more involved. That's not the purpose of this particular course, so I'll be skipping some of the more advanced features. The performance, again, depending on the type of server that is being commissioned to deploy the data lake, the performance may vary. As of now, we are okay with the standard service because we are just using it for our training purpose. It's not for production environment, so standard service is fine. There is something called redundancy. Now, this is very important because most of the server farms, they work on what is called commodity servers. So their objective is to scale out, or that's how the big data is managed. You scale out rather than scale up. And when you scale out, you have smaller servers, but they are not necessarily servers from a reputed brand. They are assembled servers, they're commodity servers. As a result, there's a possibility of downtime. Hence, you need to build redundancy. But what will be the amount of redundancy that you want to build. For example, if you build something called locally redundant storage, which is giving you the lowest level of redundancy, essentially what it means is that your data is kept in two servers in the same location, the same server farm. It only protects your data if one of the server goes down. You can take the data from the other server. But let's say the entire server, the building where the server is located, that building is not accessible. Maybe a fire has broken out or similar kind of catastrophe has happened. In that case, you will not be able to recover the data. What is the next one? The next one is something called the geo-redundant storage. Geo-redundant storage means that this is located in another uh, maybe another city or another location in the same geography. That means the same country. Okay. So obviously, if that particular building is under fire because it's located in another geography or another city, it still protects your data. The third category is the zone redundant storage. Zone redundant storage means it's a different zone. For example, here you see an Asia Pacific as a zone. So I can have another in another zone, which is let's say in Asia Pacific, Northern India, something like that, which can be my backup server. But then again, if the entire Asia Pacific zone is indisposed for some reason, I still will have face problem. So the highest level of redundancy is geo zone redundant, which means that I may have it in a completely different zone. Okay, a completely different zone and a completely different geography. So that's the geo redundant. So one may be in Asia Pacific, the other may be in Americas. As of now, since we are just doing it for training, locally redundant storage is good enough, and I'll go with that. So each of these steps will have certain configuration, and we should go to the next one and check all of the configuration. Many of them are default. So unless and until I'm specifically mentioning to change the default, you can leave it as default. So we have now gone to the advanced features. Now here we see that these REST API operations, you can leave it as default, but there's only one very important setting, which is called enable hierarchical namespace, and you must enable this. What is this? This means that you will be able to manage your data lake through some directories and folders. Remember that whenever we are having a computer, we usually manage our data through some directories and folders. Now, while we have got very used to it and we take it for granted, when you are having a new storage, it is not something that is for granted. You have to build it to use it. So in the data lake, I may want entire data to be just put up without any folder structures. Is just like putting all your data in one drive without any folder. Obviously, that will have difficulty. You will have difficulty in retrieving the data in such cases. So a better way is to create folders and store it over there. So if I want a similar kind of structure in the data lake, I need to enable this hierarchical namespace. This will allow me to create containers and directories within my data lake, which we'll soon see. Rest of the things you can keep it as default. Now here there is something called access tier, hot, cool, and cold. What does it mean? Now normally you may use the same tier both for writing and reading. Remember, I'm not talking about extensive querying, because extensive querying will need to take the data to move the data into a data warehouse. I'm talking about a regular transaction where you may, let's say, want to pick up the order number or something like that. You need to both write and read the data in order to perform even an online transaction processing system. So where the frequency of reading and writing is almost balanced, you need a hot tier, because in a hot tier, the cost of reading and writing is almost the same. But there can be some kind of data where you may need to write more frequently than reading. Whenever a new data is coming, you may have to write it, but the frequency in which you are going to read it is very less. For example, let's say I have very old health records. Now, usually once the customer is or the patient is out of the hospital, the health records may not be used. But once in a blue moon, if there is a medical legal case against, filed by a patient, then the court may ask even to dig out 10-year-old data. Now, while such incidents are very rare, you still have to store the data. In case the event happens, you have no option but to retrieve such old data. However, you want to put the data in such a place where the cost of storage should be very, very low, and you can sacrifice the cost of retrieval for it. That means you may pay higher for retrieval if the cost of storage is very low. Why? Because anyway, the retrieval is going to happen once in a blue moon, but the storage is going to happen frequently, and the storage is going to be huge because you have to keep very old data here. So you would like to have a platform where the storage cost is very low, but the retrieval cost may be high. Such kind of data lakes are called glaciers. Okay. So if you want to have a good tire like that, you should select a cold tire. Right now, we are not doing that. We're just having a hot tire. We'll go next. In the networking, we'll leave it as default, enable public access. In the data protection, we have something called days to retain deleted block. You can think of it like a recycle bin. Just like in our computers, in the Windows Explorer, we have a recycle bin. I mean, that is to ensure that the error is not too costly. If we, by mistake, delete a file, we can always retrieve it from the recycle bin. Similarly, in the data lake also, we may have to delete some files occasionally, but we need to ensure that if there is if somebody has deleted a file by mistake, there should be a provision to recover it, just like in case of recycle bin. In such a situation, you may use this feature where you specify the number of days where this deleted data, for which the deleted data will be kept, and you can recover from that. That's what the 7 days mean. The 7 days means that any deleted data will be kept in the data lake for 7 days until it is permanently deleted. These are essentially keys to control the access. As of now, we'll leave it as default. Tags are meant to search, to help you search different data lakes. In an organization, usually there'll be many data lakes, and you'd like to have some tags so that it's easier for you to search for this data lake. So if you want to give some tags by which you identify the various types of data lakes, you can do it over here. But in our case, we don't need to do that because we are having only one data lake. So we will again skip this particular step. Now, what is doing, it is doing a validation. Once the validation check is done, as you see over here, it will allow you to create the data lake. So we will now create the data lake. So initially, it will take a little bit of time to create the data lake and deploy it in the server farm where we intended to deploy. Once the deployment is complete, it will tell us that the deployment is complete. Right now, as you can see, the deployment is in progress. So we'll be getting back once the deployment is complete. You can see that the deployment is complete. And if we now go to the resource, we will be able to get inside our data lake. So this is where I go inside a data lake. So right now I have gone inside a data lake. Now, normally what we expect a data lake to do, normally we expect a data lake to get the data from different sources like, let's say, ERP system for the transactional processing, or let's say a digital media data, or let's say a streaming machine generated data, etc. We will see this in one of the later sessions, that how you can capture the streaming data. However, right now, we do not have access to a live ERP data or a live streaming data. So we will not be able to see how the data is captured over there. Instead of that, what we are going to do, we are going to upload a very small file from our local drive into the data lake. Note that this is not something that you will typically do in a data lake, because if you could store the file in a local drive, you really don't need a data lake. Okay, the data is too small. You need a data lake only when the data is big or large and the data is coming in various formats on the streaming data, etc. But for that, you need an ERP system to be connected to. For that, you need a sensor to be connected to. Right now, we do not have that setup to show that connection. In one of the later sessions, we will see how simulated sensor data can be collected, but otherwise we'll not be able to show you how that data is getting connected, because that can happen only in a real scenario where you have an ERP system to which the data lake is getting connected. So in absence of that, we are going to upload a data from our local file and see how the data looks like in a data lake, just to see how our data is structured in a data lake if it is uploaded. But as I said, I'm repeating, normally this is not something that you are going to do because this doesn't have any utility. There's no point to upload a data from your local drive into a data lake. So in order to have that, just an example to figure out how data lakes works, we will use a CSV file. CSV is a comma separated value file. It is a semi-structured data. It's a semi-structured data because it is not really a data in the form of rows and columns. It's not a database table. At the same time, it's not totally unstructured because you can derive the structure by identifying the commas within the specific records. And we'll upload this CSV file. To do that, we will create a container. Remember, we said that we have enabled the hierarchical namespace, which means that we can create drives and folders. So what is drive in a normal Windows setup is called a container over here. We'll create a container. Let's say we have some files related to automobile data. So we'll call this container automobile. You can leave this anonymous access level as it is. And within this automobile, we can create a directory, which is like a folder called cars. So essentially, we are saying that within the automobile directory, we have some data about cars, and we are going to upload this data within this. So we'll click on cars, and here we can have this upload facility. So if this facility is available, though normally that's not how you're going to get the data. So as of now, we are going to take a small CSV file from our local drive. So I'm picking up the file from the local drive. It's just like, Windows Explorer, where you go and just pick up the file. I'm just picking up the file. So this is, I picked up the file and I'm saying upload. So the file is very small, so it got uploaded very quickly. It's just for demonstration that how a data lake stores the data. And now you see that this cars.csv, which is a semi-structured file, is stored in the data lake. Now we can preview this file, click on this file, and if you go to this edit, so there are various other things, again, as I said, that we will not get into some of the details over here. If you go to this edit, here you will see the data has come over here, taking some time to show. Here you can see all the data. So you can see the make, model, type, origin, drivetrain, and length of various types of cars. As you can see, it's a CSV file. So you can only make out the structure of the data by these commas. You can preview the data. Once you preview the data, it will show you in the form of a table. But note that this is not a table. It's not that it has got converted into a relational table. It is just showing the data in a way that it appears to be a table and it is easy to read. It is also a preview. That means in this particular case, the data is small, so it is probably show all the records. But if the data was large, it is going to only show few records at the header. Okay, it's not going to show all the records. So it doesn't mean that it has been converted into a relational database system inside the data lake. Inside the data lake, the data is still in a semi-structured form. And as we mentioned in the previous sessions, if we have to use this data in most of the cases, we have to apply, extract, load, and transform through certain utilities. We'll talk about those utilities in some of the later sessions, by which we can convert these semi-structured data into a structured or an unstructured data. Sometimes you may need to convert it to an unstructured data as well. Okay. So, or a non-relational database as well. Okay. So you will need to have those extract, loading, and transformation pipelines to convert this semi-structured data into a relational database or a non-relational database. Okay. Now, during this multiple sessions of this course, we are going to create many such resources and many such resource groups. However, remember that after you have created a resource, a set of resources and a resource group, and your work is done, you must remember to delete the resource group. If you delete a resource group, all the resources under the resource group will automatically get deleted. So that way, you don't have to individually go and delete each of these resources. Why do you need to delete all of these? Because this is an account, which is a student account, which has only $100 credit. If you keep your resources running, your credits will wear away. And very soon, you will not have any credits left for training. That is the reason why, for the purpose of the training, you need to delete all the resources every time you do such exercises. However, in real industry, not all types of resources are deleted, especially things resources like data lake, which are having a persistent storage, should not be deleted. But there are some other resources that get deleted. And we'll see those kind of resources as we go along. So right now, we are going to delete the data lake that we just now created. How do we do that? We go to the resource group, click on the resource group, and here you see the option of delete resource group. When you go to the option of delete resource group, the screen will come up. You have to confirm by copying and re-entering the name of the resource group. Once this is confirmed, this delete button becomes activated and you can delete the resource group. So this deletion will be started, and you see the deletion has started. It takes usually a couple of minutes for the resources to get deleted, depending on how many resources you have. Once your resources have been deleted, you should reconfirm that the resources actually have got deleted. At this point of time, if you sign out or you shut down, the deletion process will continue. So it's not required that you keep yourself logged in till the deletion process is complete, because many times the deletion process may take a little more time than what it is hopefully going to do now, because if you have more resources, the deletion time will be more. However, it is always a good practice to come back and check whether all your resources have got deleted or not. We are waiting for the deletion here because I could have just logged out, but right now I just want to show you after the deletion is complete how the resource group look like. It should be empty. There should be no resource group called by the name of the resource group. Now you can see that the resource group has been deleted. We'll go back and check if actually is deleted or not. So you will see that no resources there. That means the resource group has got deleted. If we want to ensure that all the resources under the resource group has automatically got deleted, go to storage account and you'll see that there is no storage account, which means that all the resources under the resource group is also deleted. So remember that when you delete a resource group, all resources under resource group will also be automatically deleted. In that way, arranging the resources under a resource group is always useful, because if you have many resources And if you have to individually delete it, that may take a lot of time. Plus, you may forget to delete some of them. Here is an option where if you delete the resource group, the entire set of resources on the resource group gets deleted. So in this session, we learned how to make a data lake and how to upload a semi-structured file like a CSV file into a data lake.